Hello and welcome to our KiCad tutorial where we will be making a blinking LED matrix with a 555 timer, which looks something like this. So a standard process to build a simple circuit is to first of all build everything either on a breadboard or in a simulator like KiCad. Then we make these schematics and layout for the PCB. So in this video, I will mostly be talking about the schematics and give a general overview of the circuit as we draw the schematics in KiCad, but I will not go over the details like the frequency and duty cycle calculation of this 555 timer, as those will be included in the slides provided with this video. So we are using KiCad 7.0 here, and to create a new project, we can just go to File, New Project, and let's call it 555 timer demo circuit. Hit save, and you'll see two files. One of them is the PCB file, which we'll not be talking about today, and there will be a schematics file. We can just double click on that and open the schematics editor. So for the schematics editor, if you want to just drag around, you can just hold your right mouse button or hold the scroll wheel. Left click is for selecting, and left click and drag and select multiple elements at the same time. Okay, so before placing any components, the first thing you want to make sure is that we are using the biggest grid over here. So if we right click and go to the grid, we want to make sure we are using the 0.1 inch or 2.54 millimeter grid to place our biggest components like the 555 timer. And first thing we're gonna build is everything basically left of this line, so the NMOS and the 555 timer. So you can think about the 555 timer as a square wave generator. So if we use an oscilloscope to look at the output of this 555 timer, it's just a simple square wave with variable duty cycle and frequency based on the resistance and the capacitance of those components. All right, so to add a component, we can either click this button over here or click A directly. And the 555 timer we're going to use is the LM555XN over here, because this is a through-hole component, meaning that all of its pins goes through those pads instead of just staying on the surface of the PCB like this. And you guys will look at more details when we get to the PCB sections. All right, so let's place one of those, and if we hit our left mouse button, it's gonna place one of that. And because I have placed repeated copy enabled, now if I click left mouse key again, it's gonna place another copy. And that's not exactly what we want. So we can hit escape to exit that mode. And as you can see at this point, on the lower right corner of our cursor, there is still a symbol button. So we need to click escape again to exit that mode. And now we can delete this redundant 555 timer. Simply click that and hit delete. All right, so that's our 555 timer. Let's name this 101. This is just good practice in case, we'll have like a lot of those timers running around out there. Okay, so another simple trick that you can do if you don't want to edit every single labels just manually is that you can go to this little button here to edit all the references. And as you can see right now, we are using the first free number after 0, so we can change this to use the first free after 100. So we can set this to reset existing annotations, and if we say annotate, it's gonna change that to 101. And this works for everything after placed everything. So now if we try to place another component, say a resistor, it's also gonna follow like the 101, 102 format. After placing this 555 timer, we have a few other things that we have to place. First of all, we probably want a MOSFET, as that's what we will be using to drive the LED matrix. We hit A to add a symbol and look up NMOS. And that's the NMOS we'll be using. You can think about a MOSFET like a little switch over here. Basically, whenever there is voltage at this gate, this G pin over here, and if this voltage is above certain threshold, D pin and the S pin will be connected. And we are using a NMOS here. I'm not going to get into too much detail about the difference between NMOS and PMOS and how they are used. I'm just going to demonstrate how we are using this here and some implications of that. Like we changed this to U101, let's also change this to Q101 just for formatting. Let's add the power and ground for this circuit. So to add the power, again, we hit A and look up 9 volt because we are using a 9 volt battery over here. Okay, and this is gonna give us a 9 volt flag. Right now, we are in like the placing symbol mode. Left click again to add another symbol. In this case, we'll add the ground over here. So this is typically the ground that we use. And just OK, and put ground over here. All right, and just a little convention that we typically follow. Power flag usually points upward, and the ground flag usually points downward, just to make our schematics look a little more consistent. And now we can switch from the largest grid to the second largest for our passive components. The reason why we do that is if we place a passive component like a resistor, if we place the resistor in like the largest grid, as you can see, our cursor doesn't really line up with the pins of those symbols, because in KiCad, those symbols are kind of made for the second largest grid. So let's change that to the second largest grid. Add, and we are going to need 2 resistors and 1 capacitor over here. And do you know that this capacitor is polarized, as indicated by this silver strip over here and the look of it? As you can see, this also mentioned this is a negative pin and that's the positive pin. All right, and the resistance of this resistor is 50 K ohm, and the capacitance of this capacitor is 10 microfarads. So just to keep that in mind, when we add those resistors, 2 of them, we can change the bottom text to indicate the resistance of this resistor. So we can either double click on that and change this to say 50K. Ohm is usually like the symbol ohm is usually inferred just because this is a resistor. I can click OK, or you can single click on this and hit E for edit and change this again to 50K. All right, and we are gonna need a capacitor. So again, hit A and look up C underscore polarized. Yep. Again, because we are using a polarized capacitor, so we probably also want to use a polarized symbol over here. Again, for good practice, let's change this from R1 to R101, R2, and C02. And change the text here to indicate the capacitance, which is 10 microfarad. So now we have all the components left of this line ready, and we can start connecting them now. For the 555 timer on here, the pins numbering kind of goes like this. So see this silver or white dot over here? This indicates the pin right next to it is pin 1, as this mentioned is a ground pin, and it does align with what we have over here. And the numbering goes kind of weird, like a U shape. So it will be 1, 2, 3, 4, then 5, 6, 7, 8. So let's do the power and ground pin first, as they are, as their name suggests, they're just connected to power and ground. So we can move this 9V over here. Do make sure we are leaving a little bit of space between them before we actually connect them. I mean, if you just connect them like this, they are technically electrically connected, but this is kind of bad practice just because you don't know if they are, like, and this looks kind of weird. And so what we can do is just to drag it up a little bit and make sure there's a little bit of green line here. And again, we do the same thing to ground and connect the ground. All right. Let's look at pin 2 next. So our pin 2 here, which is this trigger pin, is just connected to the capacitor pretty directly. So we can just move everything to the side a little bit, move our capacitor here, oops, and connect it like that. Again, just for like formatting issues, please try not to do like that. And we definitely want to leave a 90-degree angle here, just, oh, not that 90-degree, but this kind of 90-degree angle here, to just make it look neat. The other end of this capacitor just goes directly to ground. So going back here, and if I'm just lazy, I don't want to look up everything again, just Control-C, Control-V, like how you would copy paste everything else, and just put it right next to the capacitor. And here's the capacitor. So pin 3 here goes to the gate of the NMOS, and don't worry about this green line here. This is just like some measurement. I'm showing you guys what the output of a 555 timer look like. So don't worry about that. The only thing you should worry about is this yellow line. So connecting this to the gate of the NMOS, we can just simply do something like this. And pin 4, in our case, is just put to high, meaning that it's connecting to power directly. So we can just, again, copy the power thing, and as you can see, like the stuff here is a little bit crowded. That's fine. Let's just move everything here slightly to the right. Also, we can move those text. Oh, that should be 101. Oops. And move that to the other side. So we have a little bit of space here to work with. And again, we want small 90-degree angle here just to make sure it look nice. And this pin 4 for us. And pin 5, this control voltage is not connected to anything. So we can put our cursor above this pin 5 and hit Q. That's gonna place an X above this pin 5. Alright, pin 6 and 7 is actually a little bit complicated over here. Oops, that's bad. Sorry about that. Yeah, moving those lines may have weird implications behind them. Alright, so we can look at pin 6 first. It has a pretty simple connection. It just goes to the positive end of the capacitor, where pin 7 has a pull-up resistor, a resistor that's connected to power, and another resistor that's connected to basically pin 6. But let's just start with pin 6 and connect it to the capacitor first. So, you know, we can definitely do something like that, or like this to make it connect, but it doesn't look very nice. And I would suggest avoid those kind of cross sections if you can. It's not like you just can't do that, but it doesn't look as nice. So a simple trick we can use is the hierarchical label. It's basically like remote lines that you can connect to So just because we are placing the threshold pin here, so I'm just gonna call this threshold and put it right next to pin 6. Connect that, and we can also put another threshold label. Again, Control C, Control V, somewhere over here. And if you want to rotate any components, we can just hit R on your keyboard. So you can rotate to this angle. And let's just put it here and move the other stuff down a little bit, just to make it look nice. Okay. So that's pin 6 for us, and pin 7, as we mentioned, have a pull-up resistor that's connected to power, and another resistor that goes to pin 6. To do that, we can have one of those resistors, let's say this one, here, and we can move everything here, just above a little bit. Again, copy another 9-volt here, and connect them. Connect that back to pin 7. Move them a little bit closer. And we want a resistor to pin 6, and so we can just move this label down a little bit. We can move this line here forward a little bit to align with the top line over here, and it seems like they have roughly the same length, so I'm not gonna worry about that too much right now. And move this resistor over here and connect them like that. So this R101 corresponds to this resistor over here, and this R102 corresponds to this resistor over here. Okay, so that's pretty much everything left here. Well, we still need to connect the power again. Paste to our MOSFET. All right, this is a little bit on the corner, so let's just select everything, move it down a little bit. And as some of you who are probably familiar with MOSFETs already realized, this is not the typical way to use an NMOS. Typically, people have the source pin of the NMOS connected to ground directly, but we have them connecting to like a bunch of LED matrix and that. This is still gonna work, but this is gonna introduce around 2.5 volt voltage drop across this MOSFET. I'm not gonna get into too much detail here, just because that requires you to know some basic logic and functionality behind the MOSFET. And if you're interested, look into the datasheet of like basically any NMOS. So this is everything left of this line, and what we have left is the LED matrix. Okay, the first thing we need is 3 more resistors that's 500 ohm each. So let's just add 3 more resistors. Again, we're using RS 1, 2, 3, and this will be R103, 104, and 105. And all of them will be 500 ohm. Cool. After that, we're going to need a bunch of LEDs like those. So we can just use a general LED symbol and give it different color a little bit later. So let's just look up LED, and that looks good. Just use this LED. And if you are lazy like I am, we are placing 9 LEDs in total. I don't even want to click my left button 9 times, so I'm just gonna put down 3 of them. And just because how I am thinking of this circuit, I'm kind of thinking about like the current going from this MOSFET down, kind of going this way to the bottom right. This is just how I'm thinking about this schematics. So I want to basically flip them because for an LED, like light emitting diode, as the name suggests, the current in diode can only flow one way, which is it's kind of what this triangle is pointing to. So it can only go this way. I'm just gonna flip them just because that makes my brain happy. Flip horizontally, and I would like those letters to align with the center of the LED just to make it look slightly nicer. And as a color sequence that we have over here on the breadboard, so we have red, blue, and green. So I'm just gonna name them like that. So you're gonna put red, blue, and this will be D1, 2, and 3. All right. So what we have to do next is just to copy paste them 2 more times. Again, just select everything, Control C, Control V, and remember to change those names to, so this should be 4, 5, 6, and so on. All right. So basically what's happening here on the breadboard is that the source pin goes into a resistor, then goes through a bunch of LEDs in parallel, and those LEDs are connected to ground. Again, that's a fact for all 3 sets of LEDs over here. So let's just do that real quick. This resistor a little bit this way. Connect that, and just because I want to place off those things like here, so I'm gonna move the text to the other end. And I'm gonna move this 500 a little bit to the right, or you can align them to the right. This is just, again, another personal preference thing. And connect every one of them. Oops, like that. So as you guys can probably already see, I have been just like left clicking on the pins to make the connections. And sometimes direction of this line follows your cursor. So sometimes if you do like up, left, and up, it's gonna do something weird like that. Or in that case, you have to go left and up to connect that. All right. So again, all of them are connected to ground a little later. That's a ground connection. So we are gonna need a ground. Again, Control C, Control V, and put it here. Left click, connect everything down. Like that. All right, and we have a few more resistor to place, but I think you guys already know how this works. Again, left click on the pin and drag them to here. Move this to the other side. Awesome. Up. 1, 2, 3. Another ground connection. You can connect them to the same ground if you want to, but I think this just looks nicer in my brain, and it's the same thing electrically. And here's the last one. And moving them to the side. And another ground pin. Okay, so this is basically all of our 555 timer circuit, and we're gonna add a little bit of other things a little later, like the battery connection and mounting holes. So after finishing off this, we're gonna place a rectangle around them and just to look at all of them as one unit. So let's switch back to the largest grid and create a rectangle around them, like putting them in a box. All right. And what we like to do is to make this rectangle dashed. And let's place on text. So this T is standing for text. If we click on that, and let's just put a label for our box over here. Say 555. This is our 555 timer chunk. Text size, we usually do 2 millimeters, and you bold this here. And something else that we want to add is the part number of like the central parts. We already have it here kind of already, but we can just add another text. So we're already in like placing text mode as indicated by the A on the lower right corner. So if we click that, left click again, and let's say LM as a part number. Again, text as 2, and we don't have to bold this. Here, 555. They are a little far apart near the corners, so we can go back and go to like a smaller grid and move them nicely next to the corners. All right, this is our 555 timer chunk. Let's go to grid, largest grid, and check if everything's aligned. And all of those pins should align with a grid, so that's good. And the lower corner is also aligned. All right, perfect. So let's move them up to this corner. Ooh, it seems like they are a little bit unaligned. So here we have so the distance here between the left edge and our paper edge is a little different than the upper edge to our upper edge of the paper. That's fine. We can just select everything again. Select everything. Change to a smaller grid. And just make it, just to move it just ever so slightly. I think that's not gonna align us with largest grid, but let's see. Yep, that does align with us with the largest grid. So basically you can do a quick calculation, like if this, like the left side is a little off from like the top side, as you can see the distance is smaller, you can just go to like the next lowest grid and move everything one grid to the right. So another trick you can do is if you hit M on your keyboard, that's moving, and if you hit like the right arrow on your keyboard. Oops. You are gonna move everything to the right just a little bit. Okay, cool. Let's go back to the largest grid that we have. So this is our first chunk. As you can see, this whole schematics paper is kind of big. That's fine. We can adjust that a little later. So the next thing we need is the battery connector. So in that case, we're just gonna use some common connector, then place the right footprint with it. I'm gonna talk about footprint a little bit later. All right, so again, hit A and go to connectors. So go to connectors, scroll up a little bit, and we'll be looking at connector generic. And because of the barrel connector that we're gonna use basically only have a power and the ground connection, so we're gonna need a 1x2 connector, and we hit OK and put it somewhere here. Again, we hit ESC to exit the repeated placing mode. Hit it again, and we can add the power and ground connection here. So again, if you're lazy, just do Ctrl+C to copy the power, put it say here, and another Ctrl+C, Ctrl+V to place a ground here. Connect that to pin 1, and connect that to pin 2. Okay. And we're gonna rename this connector from this weird COM 1x2 to terminal block. Hit OK, and this is essentially just gonna be our power and ground connection to the battery. Like we did before, let's make sure we're on the largest grid and put a box around it. And we want this to be, again, dashed. And let's name this chunk the 9-volt power input. Again, size 2 and bold. And we can move them a little later. And just because this is a power input, and we want only 9-volt power input, we don't want any other volt basically. So we want to add a warning message. Let's make this slightly bigger. And we want to add a warning message basically saying 9-volt only. So let's hit text and say 9 only 9-volt input or 9-volt battery. And it's fine leaving it at the default size. We don't want that bold. Let's have it at italicized just to look a little nicer. Put it say here. Okay. Hit exit. Hit escape to exit the placing text mode. Right click, go to a smaller grid to align the text. We can probably make this a little smaller, make the whole box a little smaller if we feel like it, but I feel like this is pretty good. And we do have enough space. Actually, let's just make it smaller to make it look a little neater. And change it back to the largest grid. And this is going to mess up the placement of the text, but that's okay. We can adjust to that later. All right, change it back to a smaller grid and move the text. Okay, so this is our terminal block. And the last thing we're gonna need are the mounting holes that I mentioned. They are basically connecting points that you can use to connect to, say, other PCBs through standoffs, or connect to like a case that you have for this PCB. So they are just mechanical mounting points. So let's just again hit A, add components, and say mounting holes. Here they are. And let's place 2 of them. Oh, and I forgot to change this to J1. And this should be H11, H12. And let's also have a little box for this 2 little guys here. Again, we should go to the largest grid, say something like that, and double click on this to make this dashed. Add text, mounting holes. Size 2 and bold. Again, change it to a smaller grid, move this to the top corner, and we can probably move this 2 mounting holes a little bit to the center or something like that. All right. This is pretty much all you have to do just for like placing the components and all of that. The next thing we're going to talk about real quick is the footprint. So the footprint is largely determined by the physical parts that you are actually going to use. And you can think about them as how pads are arranged on the PCBs. So for example, if we just look up like some random parts here, an example of a footprint would be, say, how this resistor, like how far those 2 pads of this resistor is apart, or basically how far apart those 2 circles are for this resistor. So in our case, because we already have a determined sets of parts that we are going to use, so we already know what they are going to be. If you are using different parts with different size, please feel free to change this to the parts that you are going to use. You can normally download the footprints from where you buy those components, say SparkFun or DigiKey. So this is what we are going to use here. For this capacitor, we're going to use, so this is the footprint, we want to assign a footprint to them. So click this little library icon and look up. So how this works is the left part of the search bar search for what large sets of component that is in. So we are having a capacitor and a through-hole capacitor. And the right side is looking for which specific part you are looking at. So we are looking at a radio, I think B5. Yeah, that's what we'll be using. And remember to hit OK. That's it. And for this 555 timer, we already have a footprint like associated to it, as you can see in the add component phase. If we look up LM555, you already have a default footprint associated to it. But if we look up, say, some general resistors, it does not have a footprint assigned to it. So for all the general components like resistors, LEDs, we definitely want to assign a specific footprint to them to create the PCB board. So for the resistors, we will be using resistors here, axial 0204. Let's just expand this a little bit. And we're using the 7.62 millimeter horizontal. That's what we're gonna use. And because we have 5 resistors, let's copy this, OK, and paste that for every single one of those resistors. Again, you can either double click into them, paste that, or you can hit E, like single click and hit E. All right, so that takes care of all of our resistors and capacitors. We do have a MOSFET over here, and for this MOSFET, we will be using. So for the MOSFET, it's a little weird just because the general type will be package TOSOT THT. So this is gonna be what our MOSFET's gonna use. Double clicking. And let's look up TO-126-3. Yeah, okay. And we're using the tab up version. Again, all of those just depends on what specific parts you are using, and you can change them based on like what specific part you have. All right, that's the MOSFET, and let's do the LEDs real quick. Let's look up these through hole. So SMD is surface mount, THT is through holes, and LED is a 4.0 diameter, I think. All right. And because we have like 9 LEDs, we can just copy paste this for all the other one of them. Okay. And for this terminal block thing, we are using a pretty specific, I think a barrel jack. So this is gonna be a terminal block from this specific manufacturer, and this will be a 1x2. Horizontal connector. Hit OK. And those mounting holes, and they are just the typical mounting holes that we use. So let's look up mounting holes, and we are looking at 3.2 millimeters. Add. Okay. All right. So that's, I think, all the components that we need to place and everything that we need to set up. The last thing that we need to do is to edit this section a little bit. So if we double click on, say, like the file places, an A4 is kind of big, so we can probably change that to an A5. Let's see how that looks. This is sliding a little bit, but that's fine. We can easily make this smaller. Oops. Okay. And let's go back to editing this thing. The date is just today. Revision. This is our first revision, so it's gonna be revision A. Let's just call this thing again 555 demo circuit. the noise, if I know how to spell, space ID. And say in one of those comments, we can say something like contributors and put like your name. Here. I'm just gonna say Jason. All right. That's pretty much all you have to do for this. And as you can see, we spent a good amount of time on like alignments, grids, all of that. And we are following like a set of pretty specific rules. It doesn't have to be this specific set of rules. It has to be consistent and it looks nice. That's just why we have those rules out there. All right, so this should conclude what we will be doing for the schematics part, and in the next part we'll talk about how to turn the schematics into a physical PCB. All right, see you guys then.